Superposition theorem. A linear network containing two or more sources, the response in any element is equal to the algebraic sum of the responses caused by individual sources acting alone, while the other sources made equal to their internal impedance. So if there is any ideal voltage source is there, so the internal impedance of ideal voltage source is 0, then it will be short circuited. If there is any ideal current source in the network, the internal impedance of current source is high or else infinity, then it will be open circuited. Now I'm having a circuit having two resistances. One is connected to current and another one is connected to voltage, source voltage, and this is a current I. Then let it be R1, R2 and R3. Now if I need to find out the current flowing through the RT, then step 1, we need to consider one source. So let this be Vs is present, I is open circuited. Then this circuit look like this. Now we need to find out the current flowing through R2 given by I1. Step 2. Now I is present and V is short circuited. Then the circuit look like this. Find the current flowing through it. Then we will be getting some current I2, let it be. The total response or total current through R2 is I R2, which equals to the current found here and the current found here, that is I1 plus I2. You are going to get the current, which is nothing but, since this is a linear network consisting of two sources, the response in the element R3 is equal to algebraic sum of the responses caused by voltage Vs here, current here, acting alone, while other sources made equal to their internal impedances. Here the other source is current, which I made as open circuit. Here the other source is voltage, which I made as a short circuit. This is how we need to apply the superposition theorem. Determine the voltage between AB terminals, that is VAB, for this given network. We have three sources, that is 60 volts, 10 volts and 5 volts. By seeing this network, we can say that the voltage across these two terminals is going to appear the voltage across the AB. So we can say that VAB is equals to voltage, that is 10 volts, plus the voltage across these two terminals, that is V5 across the 5 ohms resistor. Now there is no problem with the 10 volts, we can take this directly, but we need to find out the voltage across the 5 volt resistors. That should be found out by using superposition theorem, since we have more than two sources. Then step 1, only 6 volts is present and 10 volts is short circuited, 5 amps is open circuited. This is our network now. We can say the 6 volts here is going to present across the 5 ohms. So from the step 1 we can find that V5 of first step, voltage across the 5 ohms, that is 6 volts. Step 2, 10 volts is present and 6 volts is short circuited, 5 amps is open circuited. Then the circuit will be, now by seeing this you can say that the current is going to flow through the short circuited line, since the current takes the path where the resistance is low. When this is short circuited, resistance is almost 0, so the current is going to flow through this. Then the voltage across the 5 ohms of case 2 is equals to 0 volts. Step 3, 5 amps is present, 10 volts is short circuited, 6 volts is also short circuited. For the path of 5 amps, there is a short circuit path, so it is not going to flow through the 5 ohms resistance. Then the voltage across the 5 ohms resistance in case 3 is also 0 volts. The voltage V across the 5 ohms resistance is given by all this algebraic sum, that is V phi of 1 plus V phi of double 1 plus V phi of third case. Then in the first case it is 6 volts, second case 0, third case 0, so total is 6 volts. Here VAB equals to 10 plus the positive 6, so 16 volts is the voltage across the terminals A and B. So this is how we apply the superposition theorem. Remember, the superposition theorem is applicable for finding voltages and currents, not applicable for the powers. If you see here, this is the voltage, so the power across the terminals VAB is equals to, we can say that PAB is equals to VAB square divided by RAB. Now if you find this, 16 square divided by 5. Similarly, if you find the individual power losses, here power across the 5 ohms, in third case 0 by 0 or 0. Here it is power across the 5 ohms in the second case, that is also 0. Then power across 5 ohms in first case, that is 6 square 5 ohms. Apply the superposition theorem for the powers, then this 6 square by 2 plus 0 will be PAB. Now this is the power across the terminals A and B, that is 16 square by 5 watts, whereas this is the power we found by using superposition theorem, that is 6 square by 5 watts, which is obviously not equal. Therefore, the superposition theorem is not valid for the power responses. Let us solve one more problem. In this problem, the dependent source is given, that is 4V3 is going to depend upon this resistance V3. We need to find out the current through the resistance 2 ohms. Step 1, when 5 volts alone is present and 4 amps is open circuited. Now the circuit will be, assume a loop of current of I1, then applying KVL to V3 minus 5 volts plus 2 I dash minus 4 V3 equals to 0. V3 is nothing but 3 I1 dash minus 5 plus 2 I dash minus 4 into 3 I dash equals to 0. Now 7 I dash equals to 5. Then I dash equals to 5 by minus 7, that equals to minus 0.294 amps is the current flowing through the resistance 2. Now step 2. 5 volts voltage is short circuited and the current of 4 amps is present. Then the circuit will be, now for this circuit, let's apply the node analysis. Then this is our node V3. Voltage V3 is present at this node. Then the currents will flow from the node V3. Then by applying KCL at node, you can get V3 by 3 ohms minus of 4 amps is coming to the node, plus V3 plus V3. Here the current direction is this. Let this be second case, so I double dash by 2 equals to 0. V3 equals to 1.55 volts. And we know that the current flowing through the 2 ohm resistance is I double dash, which is equals to V3 this term plus 4V3 by 2. Now substitute the value of 1.55 volts, then you are going to get 3.875 amps. The current through I 2 ohms is equals to the current when the voltage 5 volts is alone acting plus the current through the 2 ohm resistance when the current 4 amps is alone acting, that equals to 3.875 minus 0.294 is equal to 3.581 amps.